Well, we would predict, if this hypothesis is true, that speciation rate will be higher in the tropical warmer regions and lower in cold Arctic regions. All right, so they went ahead and did this. They studied a large number of data from the literature and elsewhere, broke the data into 4 different bins, right, according to the latitude where the data came from. And the graph here is showing the temperature in these different areas. They measured the speciation rate using this method in these 4 different areas and looked for the correlation between the speciation rate and the temperature in that part of the world, in the part of the ocean. And lo and behold, as predicted by the hypothesis, speciation rates of these foraminifera are higher in their warm temperature in tropical areas and lower in cooler regions near the poles. So, looks pretty good then for the effective evolutionary hypothesis. The time hypothesis seems reasonable. All right, so the effective evolutionary time hypothesis seems reasonable, but didn't I just say that the mid-domain effect hypothesis seems reasonable? Huh, that's weird. Well, this is important to realize, right, in science and biology and ecology and lots of other areas, that ecology, a single pattern can have more than one factor producing it. And this is something called multiple causality, right? So just when you see a given pattern in nature, and you imagine what might be causing it, it's possible that many different things at the same time are affecting it. Just because you have one pattern doesn't necessarily mean you only have one cause, right? Multiple causality is very important to think about as you think about alternative hypotheses. It is especially important to understand when you're trying to test a particular hypothesis, because it tells you what else you have to control in order to gain insight into the particular hypothesis that you have in mind. So we're going to see a lot of this throughout biology. It happens in many situations, and it's something to bear in mind as we go forward. All right, so ecology is hard. It's really hard. Here we are trying to figure out the abundance and distribution of species diversity across the entire Earth's surface. That's a pretty hard place to start. Why don't we back up a bit and ask the question, could we figure out what controls the abundance and dynamics of things that might live just in a single drop of pond water? Okay? And that's what we'll take up next time.